So up until now, we've done really all we can to make sure that this Scorpion is as supported as possible. As we were programming this part, we were machining it. So each operation was kind of a trial and error, and we certainly had our share of errors. For the most part, operation number 1, which was our first setup where we bolted a slug of graphite to the fixture, went really well. There was really no issues. So we roughed out this entire part, and you can see there is some finished geometry that we were able to make. This is the stock at the very end of Op 1. When we flip over to operation number 2, we have a lot of material to get rid of, and we want to get rid of a lot of it as fast as possible because we can see there's a lot of open space out here that just needs to go away. Obviously the tail does need to be supported, but we did need to finish a lot of this tail before we got to operation number 2. In this file right now, I have an OptiRough toolpath with the tool and parameters we used to rough operation number 1. In operation number 1, the stock was really well supported, so we took that same operation and applied it to op number 2. Let's take a look at this operation in Verify. So in Verify, we can see our stock on top of the fixture. Being graphite, we can run this tool really fast. The step over is light, but the tool is running really quickly. Throughout this area, this tool is running great. Everything is cutting well. The further this toolpath progresses, the less support the tail has. And we can see here, we reach a point where the tail becomes an island all to itself. So right about at this point, when the tool breaks through to the other side, the tail is a very thin vertical wall that's unsupported. And in this case, right about here, we broke the tail right off the first time we made this. After watching the toolpath run and Verify, I sent the code over to MC Machinery to run, where we found out the code was not as safe as we thought it was, where the tail ultimately broke off because the tail was not supported enough. We decided to continue running that test piece just to make sure the rest of the part was okay, which it was, but of course we had to go back and adjust the process for the tail. Back in Mastercam, we can take a look at how to address this problem. The issue that we ran into, again, was the tail became a really thin, unsupported island. When using a dynamic toolpath, we want to take a full depth of cut anytime we can just to maximize the efficiency of the tool. With this Scorpion, we need to use material to support the part through the machining process. We don't want to get rid of the material as fast as possible. We need that material to stick around to support the tail. So what I need to do in this case is modify my roughing toolpath to leave some extra material that will support the tail that we can gently remove later. So we can see here that there's a large cavity of material already missing. And unfortunately, this is what we're left with because Op 1 has already been run. We need to find a way to use what we have here. What we decided to do in this case was add a dome to this part that would keep the tool from breaking through that material on the roughing toolpath. So something really simple that we can then revolve into a surface. We want to revolve this around this axis. So there's a really simple dome that we can see does not break through. Let's now add that new surface to our OptiRough toolpath and make sure that the tail has enough support moving forward. So simply add this as a drive. This toolpath is being trimmed to the stock model, so having such a big surface here is not going to be a problem. And let's generate. So here's the resulting OptiRough toolpath. Let's get rid of all this extra geometry here. So we can see this OptiRough toolpath has this nice slope that keeps the tool from entering this cavity, breaking the tail. Let's run this through Verify just to make sure. So here we are in Verify with that new OptiRough toolpath. Let's check this out and run it. And now we can see, again, the same parameters. We're still able to aggressively rough this supported material off, but we leave a nice island of material to support the tail. So at this point, we've removed most of the material, really everything we could possibly remove while keeping the tail supported. The next step of this process will be to add an OptiRough toolpath with more conservative parameters that will keep the tail supported while removing the material. Here's the stock model that shows the final stock after that OptiRough toolpath. We're going to use that to rest rough this model going forward. So let's copy our OptiRough toolpath, and we're going to reapply a new stock to our new stock model. We remove the dome from our drive surface. We're going to remove this other support surface we had originally created, and we're going to use this skinny support surface just to add a little bit more support to the tail throughout this process. Now that we've adjusted our geometry for this toolpath, we actually decided to use a smaller tool that's going to put less force into the part. So tool 12 is a 6mm bull mill instead of the 10mm flat we were using before. I also want to activate holder checking, make sure we're keeping clearance between the holder and the part. The most important part of this is we're getting rid of the large step down. In this case, instead of a light step over and a large step down, we'll change this to a 75% step over with a 20,000th step down and no step ups. This is going to allow us to gradually step down and remove material kind of the old-fashioned way, but the old-fashioned way is better at supporting the material you're cutting. The final thing I want to do is make sure our maximum depth is set to not go further than the first toolpath, and that we have a clearance plane set high enough to retract over the part. We can click OK and generate. So here's our new OptiRough toolpath that if we backplot through this, we can see a nice gradual step down. So we're keeping that material supported as we step down. And what's really nice about this is we've actually turned on Detect Undercut Stock. So as this stock model becomes undercut, the toolpath does not waste time air cutting underneath this landing. It actually just removes that material all the way down that slope. So let's open this up in Verify and check it out. So here we are in Verify. Let's take this and run it, and we can watch the tail remain supported even when we break through this first landing. So now we've gently broken through that landing there, and the tail has this nice rib that's keeping it attached to the body. These 20,000ths of an inch deep cuts really don't add a lot of side load to this part, so I'm not worried about the tail being a skinny island anymore. Now the step downs are nice and gentle. This toolpath takes a little bit longer, but the tail remains supported, and in the end, the goal is to have a tail on the Scorpion when we're done. This is how we ran the part at the machine. So we are now able to support the graphite through the process just by adding one extra piece of geometry and breaking things up. Again, ultimately speed is important, but we do need to balance speed with achieving a finished part.